Here we want to take a function and break it down into two other functions that their composition will make the original function. We have h of x equals square root of x minus 1. Our goal is to find two functions, f and g, so that when we take their composition, f composed with g of x, that it's equal to h of x. So if we take a look at our original function, all right, we see we've got the x is in the square root, and then we're subtracting that 1. So if we take this square root of x and we treat that as a function, we can say that it is the inside function. So g of x would be the inside function, and we'll just call that square root of x. So that would mean that f of x is x minus 1. So when we go to take f composed of g of x, right, we're going to take f and we're going to plug in g. Okay, so f is our outside function. We replace x. We replace this x with g of x. So we could write that as f of, and we plug in a g of x. Well, g of x is square root of x. And now making that replacement of square root of x into f of x, we get square root of x minus 1, which that gets us back to h of x. Okay, let's look at another example. Okay, let's take h of x is equal to square root of x squared minus 1. Now, again, we want to find two functions, all right, such that f composed with g of x is equal to that. So we kind of want to look inside of f and see if we can identify kind of an inside function, something having to do with x that's a function of x. Well, we've got this x squared underneath the square root. Okay, that's what we're going to call g of x. It's called g of x equal to x squared. We're going to just say g of x is that function of x. Okay, now what does f of x need to be to get back to h of x? Okay, well, f of x is just going to be a function of x again, and if we're plugging in g of x or x squared to it, that means we can make f the function square root of x minus 1. So let's go the other way to test that out. So f of g of x, okay, making the replacement, that's f of, all right, we plug in what g of x is equal to, x squared. And if we replace x in the function f of x with x squared, we get square root of x squared minus 1, which is equal to h of x. Now, there is sometimes not just one set of functions that are going to work. Okay, so this was one set of functions, right? G of x equals x squared, and f of x equals x squared, or square root of x minus 1. Now, what if we said that g of x was the inside function x squared minus 1? Then f of x, we're going to want to end up with the square root of x squared minus 1. So f of x is going to be the square root of x. So let's test that out. Let's see if we take f of g of x. So we have f of, plugging in what g of x is equal to, x squared minus 1. All right, well, f of x is square root of x, so replacing that x with x squared minus 1, we get square root of x squared minus 1, which is equal to h of x. Okay, so there isn't necessarily a unique solution when we're looking for two functions whose composition equal another function. Let's look at this one. So we have h of x equals the quantity 2x minus 1 squared, and we want to find f and g such that h of x is equal to f of g of x. So again, it's helpful to maybe start with the inside function. Okay, so we've got in parentheses this function of x, 2x minus 1. Well, let's make that, and it's inside these parentheses that then are squared. So let's make that 2x minus 1 the inside function g of x. So then what does that mean f of x is? Well, what's happening to 2x minus 1? Well, it's being squared. So we're going to have f of x be x squared. So testing that out, we want f of g of x. So f of, plugging in what g of x is equal to, 2x minus 1. And then replacing x in the function f of x with 2x minus 1, we have 2x minus 1 squared, which gets us back to h of x.